Hi there. So we are asked in this exercise to find the line current, line voltage from point A of the generator to point B of the generator, and also the phase current of the generator. Notice here that we have a transformer in a delta to Y connection, delta to Y connection here, and we have a load at this right corner of the circuit. The first thing we will do is to find the current at the load, and this could be achieved by dividing the voltage, the um, the phase voltage at the load over the load itself. We know that when a voltage is not specified, we have to assume that it's a line, a line voltage. So the voltage from point A to point V is 3,000 kilovolts, and we assume that the angle, because it's in a Y configuration, is 30 degrees. Knowing this, we could find the phase voltage at the load, and this is done by dividing and by subtracting 30 degrees to the angle. This will give us 13,000 divided by 3. 7,500 and 0 angle of degree. Now, knowing this voltage, we can calculate this current. We also know the load value, it's 20 plus 15. The result expressed in polar form would be 300.2221 with a negative angle of 36.38, 86.99 degrees. Okay, now that we have that current, we could use something called phase transformation. Sorry. Which says that the gain will be equal to the phase voltage at the primary over the phase voltage at the secondary, and this will be a phase gain, really important, and that the phase gain will be equal to the phase current at the secondary over the phase current at the primary, and this is also a phase gain. If we want to transform the voltage and find out what is the voltage at the primary, we just solve for the voltage, for the phase voltage at the primary, and then substitute. We know that the voltage at the secondary, the phase voltage at the secondary, is the one that we just calculated right here. And the phase voltage at the primary is going to be from point A to point B. So all we have to do now is substitute those values to find our voltage AB. The gain are always given in line to line, so we have to analyze these 24,000 volts. Is it line to line in the primary? Sorry. Is it line to line in the primary? And effectively, yes, it's line to line. But these 13.2 thousand volts, are they line to line in the primary? In the primary? Yes. Oh, I'm sorry. Because this gain should be phase. You have to transform the gain that you were given of the transformer if they not the phase voltage. In the first case, the 24,000, it is the phase voltage. But in the second case, the 13.2 thousand volts are not the phase voltage, but the line to line voltage. So you should divide by the square of 3, and then you just multiply that. Notice that I'm not gonna use any angle here because we're gonna determine the angle after we are done calculating. Something interesting to understand about phase transformation is that the phase angle when you transform will always be the same in the primary to the phase angle in the secondary. Later on, you're going to see that there's another type of transformation that is called line transformation. But there, the line phase is not the same. So the phase of the the degree or the angle of the phase voltage of the primary the secondary, it's 0. So the angle at the phase of the primary is going to be also 0. We're going to leave it to here, and when we come back, we're going to continue.